Okay, hi everybody. Um, Welcome to Rod Gibbons' office hours, where we're gonna share some oil industry perspectives. Um, it was a great session last week. Really enjoyed it. There was lots of good questions. Worked through some of those questions and hope to talk about them here this afternoon. Um, Also, got to meet some of you at Memorial University at the distinguished lecture. So that was great to meet some of you in person. Um, but we'll go through some of the slides that I have, and if you have questions, please put them in the Q&A, and we'll try and pick them up as we go. Or it's always good we can have if they're a bit more in depth, we can do them next week. So thank you again. Welcome to Office Hours, Oil Industry Perspectives. One of the questions that came up a couple of times last week and also this week as well was, is the oil price causing the industry to hire? The rise in oil price because of global events. So that was a really good question. So I plotted here the last 30 years of oil price. This is West Texas Intermediate, WTI, so the American oil price. There's $20, $40, $60, $80, and $100. Again, the 30 years worth of data. And I picked 30 years because I felt qualified to talk about 30 years history because that's how long. Well, I've been in the industry a bit longer than that, but I'm familiar with these peaks and troughs. And this is the average quarterly price. So you've probably seen in other places, some high hires and low lowers, but this would be per quarter. And you can see currently we're anywhere between $90 and $110 a barrel. And here's in 2022, we had quite a spike with the start of the war in Ukraine. 2020, a pretty big drop with the pandemic, COVID pandemic, shutting down a bunch of industry. There was actually one day during 2020 when 2019, 2020, when the price of oil actually went negative on one day. But variation in price is not new. That's something that's been occurring for, well, ever since there's been a market for crude oil. However, based on, and this blue line is now employment data out of the U.S. So the U.S. data is a bit easier to collate. And the yellow line here is oil price up and down. Again, the numbers they're not on this graph. This is employment index. But there's definitely a trend, and basically broadly upstream hiring, E&P company hiring, follows the oil price by about 12 months for E&P companies and about 6 months for service companies, or 7 months. So even though the price of oil goes up, it still takes time for people to adjust their budgets, adjust their projects, and then you see basically initially contract people get hired, and then as confidence grows that the oil price is sustainable, then you see employment contracts being offered. But it takes anywhere from 6 months to a year lag. And so when it goes up, there's demand for people. When it goes down, again, that same sort of lag happens. There's less demand for people. But again, this is just sort of macroeconomic, industry-wide. But it was a good question. So yes, there is a trend, and you'll probably see the benefits from looking for a work point of view in 6 to 12 months. One of the topics that we've discussed as well is around how to make yourself more appealing, more hireable. What do you need to do that? Well, so there's quite a few topics on this, quite a few opinions. I like to sum it up is that employers prefer low friction, and as I'm sure the mechanical engineers have learned, sliding friction requires a lot more force than rolling friction. And in this cartoon, the person is the employer, and the box is the person they're trying to hire. So low friction, that's where you want to position yourself. The importance of being low friction is availability, work status, readiness, and fit for the job. That all contributes to being low friction. This is the why employers prefer candidates who are easier to onboard, easier to trust, easier to place and into live engineering work. I see a question coming in here. During boom periods, does the industry mainly increase hiring, or during downturns, are people more easily laid off? Is the industry generally more stable than that? Okay, well, I'll just go back a couple of slides. So, Ali, I think you might have just missed this part, but so this is oil price over the last 30 years, boom and bust cycle. I say call it boom and bust. It's high price and low price environment. When you look at the U.S. oil price and the U.S. industry data, there's about a 6 to 12 month lag from what the oil price does to the hiring trends. So more people do get hired when the oil price is high, goes up, because and it takes about a half a year to a year, because the industry has to respond to the higher commodity price and then plan their business accordingly. And part of planning their business is planning the resources that they need to execute. So yes, it is sensitive to oil price. But again, that's on a macro scale. How do you yourself make yourself more hireable in either of those situations? Again, making yourself low friction. So what do I mean when I say low friction? Well, low friction doesn't mean less capable. It means easier to say yes to. So a low friction candidate, a candidate who's ready to enter the work environment with fewer barriers around work status, location, onboarding, communication, and job fit. High friction, a candidate who may still be strong, but requires more approvals, more relocation effort, more sponsorship, more clarification, or more time before they can contribute. In the employer view, hiring teams often compare two good candidates and choose the one that creates less delay, less uncertainty, and less operational burden. And I think it's so. And the example that I use is, if someone came to your front door and said they offered to either shovel snow or cut grass or do something around your house or apartment. In the grass cutting example, for example, it could be, and say two people showed up. One of them had a truck full of equipment, the lawnmower, the rakes, everything. And the other one said, I'm happy to cut your grass, You just need to show me where your lawnmower is. Well, one candidate has all the equipment needed, can get to work right away. The other candidate, so there's very low friction to say yes. The other candidate, I have to think about, do I trust this person with my lawnmower? Does this person know how to cut grass? You can see that there's, in your own life, you would probably pick the one that's and the price is the same, you would pick the one that is feels lower friction. And that's what employers do as well. So, and in engineering, you're talking about schedule, permits, budgets, and client commitments. Teams often need someone who can start contributing quickly. So it's not about knowing everything when you start. Everyone knows when you enter, you haven't got a lot of experience yet, but you need to be willing to learn. Offshore and regulated environments also have extra onboarding steps, and every additional hurdle increases the perceived hiring risk. So that's what you don't want the employer to think that that they're taking on risk by offering you a job. Why do employers care about friction? Well, time to start. Usually when they're looking for somebody, they're looking for them sooner rather than later, or not have any sort of delays come in. Compliance burden, visa questions, work permits, medical clearance, training, or relocation unknowns can slow things down. Team disruption. If the role is urgent, the team might not have the capacity to solve all the obstacles you get as a new hire. And decision confidence. And this one comes a lot into not necessarily the hiring manager, but more on if it's an HR department. A low friction profile feels easier to defend internally when several stakeholders must approve the hire. So these are people who are not going to get the benefit of you working, but they may get the blame if it doesn't work out. So they're looking at it from is it defendable decision. There's 5 sources of friction. There's probably more, but there's 5 main ones. Work status. So low friction, valid permit, or no sponsorship needed, no work permit needed. Higher friction, the sponsorship uncertainty or delayed eligibility. Location, you're already in the region or you're easy to mobilize. That's low friction. Higher friction, must relocate with unclear timing. Role fit, clear match to the role in the sector. Higher friction is a good profile, but it's an indirect fit. There's the link to this specific job is not entirely clear. Readiness, relevant tools, certifications, and availability. Again, something that makes it higher friction needs significant extra training first. Now, companies don't expect you to get all the training that for an entry job because you don't know what it's going to be. But with 2 same candidates, the one that's got more certificates or tools relevant to the job is going to be lower friction. And then on communication, which is, I think, when it comes to friction, communication is super important. Low friction, professional, clear, and reliable communication. That clears the path. Increased friction needs heavy explanation or reassurance. So, and this is an easy one. This is about doing your homework, researching the company, understanding what the company does, where it operates, what it's interested in, and communicating effectively, of course. Where does friction come into the hiring decision? Everywhere from when you apply all the way to getting onboarded. So your CV and your first impression. Screening. Can this person legally and practically work here? And again, it's not to say that not to apply for somewhere where it would take extra steps, but you have to do something extra to make up for that bit of friction that this might cause. Shortlisted. Does the background match the real role? This is where, and I know you've got to send out a lot of CVs and a lot of resumes. It is hard to get excited and write a cover letter for everyone, or make sure that the CV, your resume, matches the job. But this means the difference between getting shortlisted or not. And then offer confidence. Will onboarding be smooth and low risk? And so in the interview process, if you're shortlisted, the employer typically wants to know, is this going to go smooth? Is this low risk? That's you need to do your best to give them that confidence in the interview. It's not just about your questions. So question here, how can a person overcome friction not having any experience yet? That's a good question. This is not being low friction doesn't mean that you have a lot of experience. You can have a ton of experience in something. This is about, for a similar role, a similar experience level, do you give the impression that this is going to be an easy onboarding, that you're going to be able to come in and start doing the work? And if you don't have experience in doing the work, then the next best thing you can do is show enthusiasm for the work and willingness to learn the work, and asking questions and being interested. And again, this is around communication, doing your homework. So, and understanding potentially what the job is. How to make yourself more low friction. So, especially for international students and non-local engineers, because this was one of the things that we had talked about last week, if you're applying for a different region. Clarify your work authorization. State your current work status clearly on your resume and on LinkedIn. Remove uncertainty. And I think that a lot of people, engineers in the industry, are not necessarily that active on social media, but when they're hiring, they look at your LinkedIn profile. So it needs to line up with your CV, and it needs to state what is your work status, your work permit status. Build a local signal. Use local education, local address, local projects, local networking to show commitment to the region. Even if you're not in the region, you need to put in some effort to get to know the region a little bit, so that, because, and again, I'm currently in Newfoundland on the east coast of Canada. One of the biggest concerns that hiring managers have here when hiring someone who's not in this local area is, are they going to be able to move here and settle in and enjoy it here? That's a big question when transferring someone from one location to another. So it really helps to have some awareness of the locals, of local environment. In your job search, you can also target adjacent titles. So not just petroleum engineer, but integrity, facilities, reliability, project inspection, operations support roles. There's a bunch of other, and not just E&P companies, but service companies, large and small. a good way to build experience, a good way to build familiarity in an area is maybe it's not your perfect job. Maybe it's not your dream job that you want, but it's in an area where you want to further your career, like a geographic area. So it's okay to apply for jobs that are not exactly what you did in school. You can add practical certifications. Choose credentials that reduce employer risk and show immediate usefulness in the Canadian market or the local market. If you're trying to do corrosion engineering, it might help to do a welding certificate or a welding inspection certificate or a non-destructive testing training. There are things that help you understand the stuff that you're trying to engineer. So, show direct relevance, and this is one that we all have past experience. But we all don't have past experience in the role that we're applying to. So when I'm applying for a role, I will look through my resume. I will reflect on, okay, where have I come into anything similar to this at all? And I'll make sure that I highlight that so that, hey, maybe I haven't done this ever before, but I've done this other thing, and I think that might translate to what you're looking for. Be ready to mobilize. Make your availability, your willingness to travel, readiness for field or office work easy to understand. What's your situation, so that then, and not everyone is ready can move tomorrow, but at least being clear about it lines up employers' expectations. So, key takeaway: capability gets attention, low friction gets movement. A strong engineer still needs to be easy to place. In competitive hiring, the employer often chooses the person who creates the fewest obstacles between interview and useful work. And this is the same thing that you do, that as engineers, as students, as regular people, we make this decision every day, whether we're getting snow tires on or going out for dinner or whatever, sort of going to the mall, we're going to buy something. We're looking for what's the fewest obstacles, and that I get a good feeling of trust. I call it low friction. So for students, reduce uncertainty around permits, location, and readiness. For engineers, experienced engineers, translate your background into a direct, local, practical fit. Be a fit for the job. And for employers, low friction hiring reduces delay, risk, and onboarding burden. Because there's always stories of people get a job and then it doesn't fit them. And that really delays the plans that the employer has, let alone the employee, but for the employer as well. So that's a bit about low friction to help get a position. I'm going to move on here now. I see a question. What are the risks for the employer to hire someone? Well, let's use the scenario where as students, you're going to graduate and you're going to start your own company, because that's also a possibility. But in this company, you need a 30-year experienced engineer to come do some work for you. Okay, well, I see this job posting and I think, okay, that's great. But if you hire the wrong person, well, what you're going to do is you're going to spend money. Probably, I mean, you can do it on social media now, but most companies will spend money to advertise the position. So there's a cost involved. Then you're going to get resumes in. You have to take time to review them, shortlist them, and then do interviews. So there's a real cost. There's an investment in money, whether you're flying people in for interviews or you're doing them online, but there's still you've still spent some money to interview these people. But most importantly, it's time. It's your own time. You more than likely that whatever business that you started, it's probably not the point of the business to hire people. It's probably the point of the business to do something else. So you're spending your time trying to hire someone who's going to do work to help you to so that you're more productive, not less. When you do your interviews, you make an offer. If that person is got a work permit issue that wasn't told about, or has got a delay in coming to work for you, then you have to make a decision. Do I keep going with this candidate, or is this not what I can handle? Say, oh, I've got other work and I can't be there for 6 months. As a business owner, that's a decision you have to make. Then, if the person shows up, but they don't fit into the team, or it doesn't work out, or in an interview, people get very good at interviews and very good at being able to say the right things for a half hour or an hour. It becomes very clear in the first couple of weeks of work if what you got as an employer is what was advertised in the interview. So then say it doesn't work out. Then as an employer, well, it's not fun to let someone go. That's not fun. No one wants to do that. And the person who you've hired may have left another job. It's a disruption to their life. That's also not easy to deal with. I found it not easy to deal with. And for the company, you may have spent 3 to 6 months in this process. Only now you have to start it again. And that work is still not getting done, and you've spent a bunch of time on it. So there's a big risk as an employer. And that's why it's important to try and reduce your friction. Try and make that risk as low as reasonably practical for the employer. And I think, because as job seekers, we're looking, what can this company do for me? As companies and business owners, we're looking for, what can you do for the company? So it's got to be a two-way street. So thanks for that. I'm going to switch gears here now. There was a question around bridge plugs that came up this week. So this next topic is bridge plugs, and we're going to talk about what is a bridge plug and how they work and what do we use them for. So a bridge plug is a downhole barrier used to isolate a lower interval, hold pressure, and enable completion, intervention, or abandonment work. And so, well is drilled, you have casing and cement, and here's the rock. So this is a cross section, of course. And then, if you need to isolate the lower zone, a bridge plug is what's used in industry to stop pressure and fluid from coming out the well. I'll show a few the components of this. So again, it's used for well control, selective operations like testing or squeeze cementing, and then it's also can be used as temporary or permanent abandonments in the well. And in practice, it's a mechanical a stopper that goes inside the casing or tubing and isolates uh, one zone from another. And how it works is, well, I think there's a slide on how it works, but really what it does is these green parts here are called mechanical slips, and they're activated and slide out the cone, and that secures this plug in the pipe, and then hydraulic pressure is applied, and the plug is squeezed together, and this black element here is typically some a type of rubber elastomer, and it squeezes out to form a seal against the casing wall. So then that gives you a pressure seal from below. Historically, in the 1920s and 1950s, cement plugs were used. So you just pump cement in the well and let the cement harden, and then that would be the plug. 1960s, mechanical plug patent was filed, which has dual slips, a compressive packing, and a locking mechanism, very similar to what we use today. In the 80s, drillable cast iron bridge plugs came into being, and a mechanical plug, when it's got a lot of moving parts, if it doesn't come out and you have to drill it, then a lot of those moving parts can move, and then it's hard to drill. Whereas a drillable cast iron plug, bridge plug, it's permanent, but if you need to remove it, there's not a lot of moving parts left in there, and the cast iron will drill very easily, so you can drill it out easy. And then in the late 90s and the 2000s, more composite bridge plugs for more focus on multi-stage fracking, so different types of materials. And now in the 2010s and 2020s, we got high-spec barriers, some of which can hold 25,000 psi differential pressure, which is a lot, and 500 degrees Fahrenheit temperatures. And then there's also dissolvable materials where you can set the plug. It forms a pressure seal, but the materials is actually reactive with a chemical, so then it can just dissolve away, which is really cool. And again, so how it functions, how a bridge plug functions. You've got the upper slips, hardened steel teeth that engage with the casing or tubing and resist moving upwards. And then down here's the lower slips that provides that latch in and into the tubing or casing and resist downward movement. So it's anchored this way and that way. The cone or expander, so it's just like a ramp. So if you think about this as in a very tight tolerance, this can be run through the pipe, but if it has to go out and ride out onto this cone, that's what squeezes this into the pipe. And then the packing element, again, elastomeric seal, which forms a pressure seal, and then a locking ring that keeps that in place. And then on the bottom is a guide so that it runs into the well smooth. There's two ways to set them. You can set them on wire line, slick line or electric line, or you can run them on pipe and set them hydraulically. And in the pipe case, you would have a ball that would drop. You drop a ball and it would form a pressure seal, and then you could pressure up from surface and set the plug. On wire line, you could use a running tool which will stroke the bridge plug. What does it look like in the field? It's basically a slick line lubricator and slick line operation. Couple of different. Here's a plug here and a about to be put into a lubricator, and then offshore, very similar setup, just on the intervention deck. So currently used for completion and stimulation work. Creates remedial cementing. They make a great base for squeeze cementing. Well suspension, use them for temporary abandonments. And then also they can also hold pressure in both ways for pressure testing. And then plug and abandonment, lots of times they'll be used as a temporary plug, but then cement will be added on top for permanent plug and abandonment. So then you have a mechanical plug with a layer of cement on top of it. And yeah, so the research and development, again, is a lot around material selection. Cast iron is very common. Composite, again, in fracking operations, like say lower density, faster drill out. Elastomers, there's a whole science behind making sure that you have the right elastomer for the right wellbore fluid so that they're compatible. I would say dissolvable plugs are becoming more and more common as well. And then there's certain standards in testing to make sure that the plugs are reliable. Some of the challenges and failure modes. So, and again, this is not a cutaway. This is sort of a full look. But premature setting happens where you're running in the well and it sets before you actually get it in place. But having anti-preset mechanisms and controlled shear pins help to avoid that. Seal extrusion or leak off. Again, making sure that your elastomers match your well conditions. Slip damage or casing bite issues. Sometimes you have issues when you have very, very hard casing. Sometimes you have to make sure that the slips are the right hardness so that it will not slip on that hard casing. Restricted ID or limited access. Sometimes you want to get through a small obstruction and set the plug deeper. So there are some high expansion plugs or inflatable plugs that can that solve that. And then slow or difficult removal. Again, a permanent drill plug, a permanent bridge plug has the advantage of being easier to drill than a retrievable. But a retrievable, if it doesn't retrieve, can be somewhat difficult to drill out. Again, dissolvable materials is really making a big difference in that area. And then harsh service, high pressure, high temperature, corrosion compatible, and certified gas tight barrier. All those are possible. Again, it just takes a little bit of upfront work. So, and again, where the technology is heading, again, composite dissolvables for less mill out, smarter setting systems. So we've been using the same setting methods for lots of years now. There's potentially some gas pressure applied and other ways of setting that are interesting. And then also high assurance barriers. So there's a V0, V1, V2 sort of qualification system, and so you can get some very rigorous testing and highly qualified bridge plugs. So bridge plugs are small tools, and they have a big impact from simple barrier to engineered assurance tool. It's a very good tool in our engineering toolbox for downhole well tools. So there was a question on that earlier this week. So now we've talked about sort of the industry high level trend. Talked about um, how to get to create conditions where it's easier for someone to hire you. We talked about a bit some equipment that's got some interesting stuff in the industry. Now I'd like to spend a little bit of time on, I call it, is petroleum engineering a good career fit? That was one of the questions that was asked. And a spoiler alert, yes, it is. So, and I do want to say that things are very positive in industry. There is a demand for people, and as I said last week, a diversity of people. So I just wanted to go through just some of the fits in petroleum engineering, because petroleum engineering is kind of a broad category, and I think there's opportunities for lots of different types of people. So there's kind of six. I've used six different distinct areas in petroleum engineering, and think about, if you could have any job that you wanted, what job fits you best? That's the ideal place where you want to be. So you need to look for a section that matches your way of thinking, your interests, your how much pressure you're comfortable with. So, and again, careers are built by more than competence, safety, judgment, communication, and consistency than by stereotype. There's lots of different personalities and lots of different people in the industry. So in petroleum engineering, production and operations, it's more fast, practical learning and direct asset impact. Reservoir engineers, analytical, strategic, long-range field decisions. Drilling and completions, high pace, execution, and pressure control discipline. Facilities and process is more systems, equipment, broad cross-functional value. Integrity, reliability, safety, trusted risk reduction and life cycle judgment. And projects, interface, and planning is structure, coordination, delivery, and leadership growth. Those are, in general, the broad categories of petroleum engineering. And then 6 strong fit areas. Okay, so we just talked about the different type categories. Technical depth, they're all fairly high in technical depth, maybe less so on projects, interface, and planning. Field exposure, this can be anywhere from high with production engineering or operations engineering to low with reservoir engineering, high with drilling, and then sort of middle in facilities, reliability, safety, and projects. The work style ranges from fast and practical to analytical, intense, execution-led, systems-based, structured, preventative. Leadership path is all very strong if you wanted to develop into a leader in a company. Projects, interface, and planning is probably a bit more strong. So it's a little less on the technical depth, more strong on leadership. Flexibility, they're all flexible. You know, drilling and completions, medium. It's somewhat specialized section. And then what is best for? Production operations, best for asset-minded people. Reservoir engineering for model thinkers. Drilling and completions, pressure ready. You're in execution mode a lot. There's lots of day-to-day pressure. Facilities and process engineering, broad builders. They enjoy sort of bigger, a longer, broader view. Integrity, reliability, safety. if you're detailed focused, that's a good attribute to have there. And then projects, interface, and planners, organizers. That's best for it. Again, all these can fit different personality types, but this is in general. Production operations engineering. Engineers want a broad asset understanding, so best fit if you enjoy troubleshooting live problems, optimizing production and uptime, working closely to field reality, making practical decisions quickly. So it's a long-term job role, and it's versatile. There's lots of variety in it. Reservoir engineering. Strong for engineers who like subsurface reasoning, uncertainty, and long-term field strategy. So modeling, interpretation is a really good fit if you enjoy modeling and interpretation. Decline trends and forecasting. Uncertainty and scenario thinking, and data-backed decision logic. So also long-term and versatile. Drilling and completions. If you like high pace, technical execution, and disciplined control under pressure, then drilling and completions. If you enjoy time-critical decisions, rig rates can be very high on a daily basis, so there's always a sense of urgency to make decisions. Well planning and execution, equipment and barrier thinking, and operational intensity. Facilities and process engineering is a lot of times the best all-around choice if you like systems, equipment, and long-term flexibility. If you enjoy flow, pressure, separation, fluid treatment, I would add chemistry in there too, maybe. Equipment and system design, cross-functional technical work, balancing safety, operability, and cost. Integrity, reliability, process safety. If you want to become trusted for your judgment, prevention, and disciplined technical thinking, it's a good fit. So if you enjoy failure prevention, risk reduction, and barrier thinking, inspection and reliability logic, structured review, and follow through, then this is a good part of petroleum engineering to focus on. Projects, interface, and planning is strong for engineers who are technical, but also who are naturally structured, organized, and good at keeping complex work moving. So if you enjoy coordination across disciplines, turning plans into aligned execution, tracking scope, schedule, and interfaces, clear communication under pressure. So those are, I guess, diversity around ways of thinking styles. There was a question about demographics, and so I guess the top line is the industry is not evenly represented yet, but the direction of opportunity is broader than the old stereotype suggests. So 24% of women are in Canada's energy sector, 20% visible minorities, 30% women in senior management roles across Canada, and 23% or 18% female/non-white chair in U.S. led company oil and gas workforce. So it's not 50%, it's not 50, it's still underrepresented, but as I said before, the attitude is very inclusive. So best career advice I can give is choose a section that fit the section in petroleum engineering that fits your strengths, then build a reputation for technical depth, reliability, and clear communication. That's the best way forward, regardless of demographics. If I was going to recommend something, well, again, this is general suggestions. Best all around, facilities and process gives you technical depth, flexibility, and cross-functional value. best for fast practical learning, production operations, daily exposure to asset performance and operating decisions. Uh, which I personally enjoy doing. Best for analytical depth, reservoir, strong technical credibility and long-range field logic. And best for structure and future leadership is in the project interface planning, which gives you, because it gives you broad visibility and coordination-driven growth. So with that, I think just check the questions. I think that's about it. I just see a question here. Thank you for Hello, thank you for the lecture. My question relates to last week's presentation. With the development of Beta Nord, how do you think this project will reshape talent demand and job opportunities in offshore industry over the next few years here in St. John's? Also, as students, which technical skills and soft skills should we prioritize to become strong candidates for this type of project? Well, good question. We did talk about Beta Nord last week a little bit, briefly. That's a new project that is going to. It's a mega project. It's going to take years to develop. Once project approvals are in place, it's going to take time to develop, and it's going to need engineers. 100%, absolutely. I want to go. I did have this. This is the oil price graph again, and then just off of this graph here, there was a mega project called Hibernia that really kicked things off in this area as well. So, when you're looking for technical skills, I'm just going to look at the question again. How do I think it's going to impact job opportunities? I think it's going to be I don't know what Equinor's timing is, but it feels like in 3 to 4 years there's going to be a lot of opportunities here locally. How do you position yourself for that? Well, I think if we go back to being on the low friction talk, you're going to build technical skills, learn as much as you can to make yourself as low friction as possible to move into a role in a large project. So if that's where you would like to be, I mean, sure, submit a resume to the operator. They're probably, I can't speak for them, I don't know, but they're probably not ready to hire a bunch of people just yet. But there's lots of service companies and other companies in the area who are also starting to get, who are active and who are going to see more work coming in. That's a great place to get involved in a project. So I think the key technical skill that I would recommend would be communication skills. Find out what you can do for a hiring company. What are they looking for? And then show them how you can do that. That is, I think, one of the key things. And then I always talk a lot about petroleum engineers, mechanical engineers, civil engineers, naval arcs, electrical. All the engineering disciplines will be required. It's about developing yourself as a person to have something that people want to hire, which is, and not everyone is looking for the same thing. Not every company is looking for the same person. So you could be a great fit for one company and not a great fit for the next. You just have to continue to apply, to talk to people, to network. And that's what I wanted to close on is this oil price has been down. Well, this is $10 a barrel. It showed 100 for the quarter, but it was up to actually 200. This up and down in the industry, projects starting, projects winding down. This is ongoing. This is 30 years ago. We were never worried about this. 60 years ago, my parents were worried about it in the industries they were in. So this finding a job that you like and enjoy, that nothing's changed. The tools have changed. I was looking in the classified in the newspaper. You're looking on Indeed or LinkedIn. The tools have changed, but the process is the same. Companies are run by people. Those people are looking for other people to work with. You want to make yourself as valuable as you can so that more people want to hire you, want to work with you. So again, the stress of finding a job is real, but it's not new. And it doesn't go away. It does. You get more used to it. But I want to end on a positive note that there is work out there for you. There is a really good fit job. It's difficult to find it because it's difficult to know what you want. But it is worth the time to have some simple self-reflection. What kind of job would fit you? And when you're looking at job postings, okay, what would make it great for the employer to hire me? Other than you getting a job, what's in it for them? And because this is probably going to continue for the next 30 years. It's not going to go like this, and it's not going to go like this. It's going to go like this. So, but that's okay. We can still have a very enjoyable career in the oil industry. But thank you for the question. Really good one. If you have any more questions, please put them into the Q&A. And just a reminder, so next Wednesday, we'll do office hours again. I still have quite a few questions we got to get through here. Sorry, I apologize, I didn't get through everything that we talked about last week, but I thought it would be more valuable to give a bit of a deep dive into these things than just skim over them. So, but next Wednesday, 9 o'clock Newfoundland time, 5:30 in Alberta. We'll see you then. And so have a good night, everybody.